Hi, in this video, we are going to build a deep learning time series model using DeepAR. Now, DeepAR is a supervised learning algorithm for time series forecasting that uses recurrent neural network to produce both point in time as well as probabilistic forecast. DeepAR internally trains a auto-regressive recurrent neural network for producing probabilistic forecast. The best thing about DeepAR is basically DeepAR can work seamlessly on multiple time series. So typically when you build a multiple time series, say you have a retail and you have a retailer has thousands of product, you typically tend to develop separate time series model for each and every product because every product will have a different sales cycle in the retailer, right? If you are dealing with the sweaters may go well during winter, but during summer not that much. But if you are going with the swimming gear might go better during summer and not during winter. So every product has different time series over here, and typically we develop multiple local models. But DeepAR can work on to create a single global model when you have such scenarios, when you have multiple time series scenarios. And the best part is it has a inbuilt special treatment for case when the magnitude of the time series vary widely. So it can also help you, right? The scenario I was talking about the sweaters and swimming gears, these have varying time series, and DeepAR can handle that seamlessly by developing one single global model. Not only that, typically when you initially do not have data, you have a cold start problem. May a DeepAR can see whether what is the closest model that develop applies to that pattern, and it can also use it for unseen data. While it may not be reliable, but at least like it's a good starting point to estimate a forecast and then keep monitoring it over time. So we are going to see how we can build a deep AR estimator. And it's one of the good thing is you don't have to define a neural network model or something like that. You will just do it by configuration. And other part is it is available as a service in AWS Sagemaker. So if you're using Sagemaker to train your model, deep AR is bundled within their models, so you can directly use it. So let me get started. Now, the first thing I'm doing is I'm installing GluonTS. GluonTS is an open source package for time series, and internally it uses Apache MXNet to develop deep learning models. And DeepAR Estimator is part of GluonTS. So I'm installing GluonTS. There are two versions. If you want to install the GPU version, you can use the one commented on top. This is for CUDA 101. If you're using CUDA 9.2, you can just check for the respective version. But I'm going to use it on CPU, so I'm just doing an pip install mxnet 1.6.0 and GluonTS. I have already installed it. Then I am installing a set of libraries. I'm using pandas for loading my data, matplotlib for visualization, Gluon, basically DeepAR estimator for modeling the time series model. Trainer is where you can customize and define additional parameters, GluonTS trainer. We will see more about it, and NumPy for just handling the data. What I'm going to do is I'm going to use the energy consumption data that is available in the UCI repository. You can just follow this link or search for energy data UCI in Google, and you will get the link to the CSV file. I am using that data set. Let's quickly see more about the data set. So I'm loading the data set. Let me run DF, and you can see over here these are the different variables that are available. I have date, I have appliance. Basically, this is the energy that is consumed by home appliances. This is the energy that is consumed by lights, and these are different temperature in different rooms. Like T1 is the living room temperature, humidity in the living room. T2 is the kitchen temperature, humidity in the kitchen. Like that, there are variables defining temperature and room in temperature and humidity in each and every room. In addition to that, we also have outside temperature. So basically, I will show you, like when I run on a subset of data, we also have outside temperature, outside humidity, and other things in the data set. Right? So what I'm going to do is first is, since I have like multiple, each of this T1, RH1, T2, everything is a time series. I want to visualize and see which is the variables that are mostly influencing appliances. I'm just quickly visualizing it. I don't know yet because I'm not running a statistical test. So I'm just going to quickly visualize it. Now I have a lot of columns over here. In this case, I have around 29 columns. So rather than running visualization individually, what I have done is I have created basically a function that will iterate and run for all the variable. So for that, what I'm doing is I'm just defining a color list to randomly pick one color for my graph. By default, if I don't give a color, it's going to use blue color, so all the graph will look similar. So I'm just adding some kind of colors to the graph. That's what I'm doing over here. I'm telling my date key is date. So basically, since a time series data, this is the date key over there. And if you see the date key, I have data from 2016, basically November till around 2016. Sorry, 2016 January. It was 1101. That is January 11th. Till 2016 May 27th. So this is the data, and the data is every 10 minutes. So I have 5:40, 5:50, and 6 o'clock. So every 10 minutes the data is, and my column that is having the date is the date column over here. So I'm telling my date keys in the date column, and I'm creating a function. In the function, what I am doing is I am getting all the feature list that I have. So basically, I am taking the all my columns. The data frame dot columns will give me all the column names. I'm telling select only columns which is numerical. So I don't want the date column because there's no point in visualizing the date column, and I'm getting the values out of it. So I will have, in this case, I will have all the features, and then I am iterating over here through each and every feature, and then I am basically plotting the data. I'm just telling the t underscore data dot plot. So you can quickly go. It's very simple function to understand, and I'm randomly picking the color over here. And also I'm just like showing some kind of legend, that is the incoming key over that the particular series pertaining to. And then I'm calling the visualize function using the data frame. So what it will do is, once I pass the data frame, it's going to go and look at all the columns. It's going to iterate to each and every column and plot it for me. So rather than plotting all the 20 columns one by one, it's just going to learn a function in the loop and do the plotting for me. So if you see over here, I have all the plots now, right? So let me go on the top, and you can see basically I have all the plots in this case. Yeah. So you can see this is how the appliance behavior is. And if you see the earlier month, the appliance usage is higher. Similarly, the light usage is higher. And this is around like January 11th. And you see January, typically it's an winter month. So looks like the winter has higher appliance usage compared to as we go into the warmer weather and the hotter weather, right? Similarly, you can see the lights during the winter, the lights usage may be higher. But during summer, you have plenty of light. So maybe it's coming down, right? So, and then I have temperature in each and every room that we saw. That we saw. But what I'm going to do is I'm going to scroll down, and I'm going to use just few variables from the outside temperature. Let me quickly go to that one. Yeah, so I'm going to use this. This is the outside temperature, where you can see during the earlier January month, the temperature is pretty lower because it's typically winter or a warmer weather. And as the month goes on, the temperature increases. Similarly, the pressure also has a pattern. The pressure is like kind of falls lower during the initial months, and then it's kind of oscillates to higher. And similarly, I have humidity, right? So what I'm going to do is I'm going to create data frame with only columns date. Appliance is my target column. The idea goal over here is to predict the appliance usage for the next 7 days. That's what I'm going to do. So considering the historical pattern, for the next 7 days, I'm going to predict my appliance usage. And then I have my temperature output, my pressure, outside pressure, what it was. I'm not taking individual room. I'm going to skip those variable. I'm just taking the outside temperature, outside pressure, the humidity outside, wind speed, dew point, and visibility. These are some of the variables. And I'm creating one more data frame over here. Now, what also I am also doing is I'm setting date as an index so that I can easily query the data. I can slice and dice if date is my index. So I'm just querying I'm just setting that as an setting that variable as index, and then I'm setting my train time. That is my starting, or I have a data from January to May, right? I have data till 27th May. That is what we saw. If you see in the graph also, you can see. So I have data from January, and the data is till 27th May. If you go to the top, I have till 27th May. So what I'm doing is I'm trying to get my training data only till only till 10th of May. The remaining I am going to use for evaluating my model, for testing my model, and we are going to perform some back testing also. So that's what I'm going to do over here. So I'm taking my training time till 10th of May, from January till 10th of May, and telling my prediction length is 144. So what is this prediction length 144? I have 10 minutes data. That's what we saw. So in a hour, I have 6 data observations. In a day, it's 24 into 6. I have 144 observations. So I'm telling I have to predict for 1 day of appliance usage. That's what I'm trying to do over here. If you want to predict higher, you can make it 288 for 2 days or keep on increasing it. But I'm going to predict for 1 day of data, and I'm creating my estimator. So now this is the best part about DeepAR, right? Now typically when you create a LSTM model, this internally creates an RNN model, a LSTM model, right? Now when you typically create, you have to define your model, you have to add layers and all this stuff. You might have seen in my previous LSTM video using TensorFlow, but in DeepAR I can do that as well. I can customize my model, but I can just, as simple as this, I can configure it. So in DeepAR estimator, what I'm telling is, I'm telling my frequency is 10 minutes because my data is every 10 minutes. The context length is how much previous observation I need to take to predict the future events. So I'm telling my context length is 720. So 720 means like 144 is per day, 144 into 5 is 720. So I'm taking previous 5 days of data to predict the next 1 day. That is the prediction length. So in the context length is previous 5 days of data I'm taking. I am predicting the next 1 day of data. I'm telling I need 2 layers, a deep learning model, and I'm telling my cells in each layer is 128, and the cell type is LSTM. Right, so I have defined an LSTM model with 2 layer, which both has 128 number of cells. And I'm telling the trainer object that I have to train for 8 epochs. Now in the trainer object, you can also give learning rate. You can give also all the other information that typically you feed the deep neural network. But internally, it will go with defaults. Now, if you want to customize the layer further, you can also define your own model and pass it on. But I'm going to go with this, right? So it's as simple as that. I have created an estimator. That means I have created a deep learning neural network framework, right? Or I have created a model object. Now what I'm going to do is, I am going to give data set to it, right? I have a model, I need to feed my data to it. So for that, I need to give some metadata about the data, and that's what I'm doing over here. So I'm creating an list data set object that's in GluonTS dataset, common list dataset. In the list dataset object, I'm telling my training data as the variable. The start time is the df input dot index. My date is my index column. If you remember, I have set date as the index column. I'm taking the 0th index, that is the January data, 1101 data. And I'm telling my target is basically the appliances value. In this case, I'm going to do univariate analysis. But in my future video, I will show you, I want to keep this simple. The reason is building and multivariate analysis is little tedious in the preparation step. So let me start with univariate. Let's get an understanding, and then I'll go to move to multi-time series and multivariate models, right? So in this case, I'm telling appliances is my target column. So basically, I'm using only appliances previous value to predict the future appliances usage, right? And I'm telling train time, that is the 10:05 May data that I have given, that is till take data till that time. The remaining data I'm going to use for evaluation, and I'm again telling the frequency is 10 minutes over here, right? So I have created this data set. Now it's as simple. I have the estimator object, that is the model. I'm telling model that estimator dot train. I am passing this training data to over here, and I will finally get a trained predictor, right? So let me run this. And what it's going to do is, it's going to go and train the model. This will take some time. It or you can run it on GPU to speed it up, but since I'm now running on CPU, it's going to take some time. It's going to run for 8 epochs, and it's going to, by default, it's 50 epochs, 50 steps per epoch, but you can reduce it, or you can do whatever you want to do in the configuration of the estimator. But I'm going to accept most of this default. So let it run. After this is done, I will come back and continue, and let's see how the model performs. Okay, so now the model training is complete, and we have an predictor, a model output over here, a trained model. You can see basically we trained for 8 epochs, and the average loss is coming down. Typically, depending on your complexity of your data, your size of your data, the number of variables you are using, the number of time series, you may want to run for a lot of epochs for this model to learn better. But overall, we can also give an early stopping. If you see the loss is not declining, you can also set that in the trainer object. But we know we have a model now. What we are going to do is, now we are going to do some back testing to see the performance of the model against unseen data set. So if you remember on the top, we took 10th May as our training time, the last time. So we are taken data till 10th of May. What I'm going to do is I'm going to create a training data set now, or a test data set now. Rather, and then I'm creating two instances of it. So I'm going to validate against two test data instance, and one is basically at of 11th May, after the training time, and second is 15th May. So these are two instances I'm going to back test against. But what you can also do is you can give more back testing scenarios over here, right? And again, the frequency is 10 minutes. So here I'm just defining the metadata. Now what I'm going to do is, from the Gluon package, I'm going to import this make evaluation predictions function that is in the backtest folder within GluonTS, right? So I'm importing that, and then what I'm going to do is I'm going to call the make evaluation predictions function. I'm going to pass the test data that I am defined on the top. I'm going to pass the predictor, which is nothing but our trained model, and I'm just giving like run for under 100 samples, right? It's going to kind of randomly run for 100 samples and give us the output, right? So it is also going to simulate internally, so that it can give us the confidence interval of all the probabilities of the output, right? The forecast is one part. You may have a forecast, okay, the sales is going to be $200, but you also want to know a confidence range, like what is the 95% confidence rate, what is the 50% confidence range, so that your forecast might not be accurate, it can be plus or minus. You want to handle that scenario, and that's where you will also get a confidence interval. So I'm going to run this, and then once it is run, I have two object. One is the forecast and the actual input value. I can just create a list and assign that to a variable. So if you see over here, I'm assigning it, and then I am picking the first forecast so that I can quickly see how the forecast looks like. If you want to directly work on the forecast, you can use it. So here, if you see for the forecast, and the first zero gives me the 11th May output. The forecast of one will be give me the 15th May output. So I have taken the 11th May output now, and you can see basically this is my 7 days prediction. That is the 144 prediction length I have given. It's given over here. Now, rather than seeing the prediction length, I want to visualize how my forecast is similar to my actual underlying ground truth, right? So that's what I'm going to do over here. I am creating a function that will plot me my forecast and the observed value, the actual observed value. So in this, what I'm giving is I'm giving a prediction length, which is nothing but 144. I have predicted for 1 day on the top, and I'm taking the 80% and 90% confidence interval, and then I am plotting the particular data, and I'm passing the input values over here, the input observed value and the forecast value that I got from the top. So basically I got the forecast IT and the TSIT. I'm just going to pass it over here. So I have this function, and then what I'm doing is I'm calling this function with the input value and the forecast value for both the test values I have given. I have given two test values. For both the test values, I'm plotting it. So now let's see how our model has performed. Now let's go with the first one. If you see, this was the first one, and you can see basically the blue line is the observed value, the green line is the predicted value, the dark green line is the 80% confidence interval, and the light green is the 95% confidence interval. So typically, like, our model is doing a good job. There's a huge spike, and if you see the model, 95% confidence interval also captured that particular spike, right? So basically our model is in the range of 95%, or most of the time it is in the actual forecasted value, right? This is with the first observation that was on 11th May. On 15th May, in contrast, like, what we are seeing is model is doing good, but this spike is not captured as well, right? And even this spike it is trying to capture but not the exact peak. And similarly here also it is telling a peak but not the exact peak, right? And that's where maybe we need to add more variables, like maybe we need to add temperature. Typically the energy consumption depends on temperature, or if it's a residential area, if it was a holiday, because in holiday people tend to stay home, that is a high energy consumption. So there are a lot of other factors that may come into play, and we want to see like if we adding that we can improve it, right? So that is what we are going to see in the future videos. But here we are doing a univariate. I can also quickly evaluate the model. The from GluonTS I am calling evaluator. I am setting again the quantiles like 10%, 50%, and 90%, and then I am giving the forecast and the value that I have predicted. So once I have it, it will give me for each of the run what is the mean square error and everything. If you see the first time series that we predicted, the mean square error is 833, but the second the mean square is high. We saw that in the graph as well, right? But what I wanted to show here is how you can use DeepAR. You can just use by simple configuration. You can build pretty complex time series model with DeepAR. And as we go into multiple time series, you'll see like how much benefits DeepAR gives you compared to building your own single local models. So we will check all that in the future videos. But this is a video to get you started with DeepAR. I wanted to keep it simple, not adding much variables, so that you get an understanding of various steps over here. Thank you very much.